All right, so today's notes are on absolute value functions and function transformations. Our content objective is to graph absolute value functions and their transformations and write their equations, and to also describe function transformations. So we have sort of two objectives that we are combining into one, since they actually are in a lot of ways the same thing. Our language objective is to use terms including reflection, stretch, compression, and shift/translation to describe transformations. So we're going to learn about function transformations through our practice graphing absolute value functions. So we're going to focus specifically on absolute value functions today, but the function transformations we're learning actually apply to all functions that we will learn about this year. And so we'll see the function transformations come up repeatedly throughout this school year. So absolute value function. The most basic version or parent function of an absolute value graph is f of x or y equals the absolute value of x. So if this ends up having a V shape. So since it has a V shape, it has a vertex, which is just a maximum or minimum point to your whole graph. So the vertex is the maximum or minimum point. We'll use that terminology a lot. So make sure you remember vertex is the maximum or minimum, and it has a slope of -1 or 1 on either side. So this side has a slope of -1, this side has a slope of +1. And this again is the simplest version of this graph. So we can actually go ahead and graph this absolute value. So that side has a slope of -1, this side has a slope of +1, and you end up with a V-shaped graph. So I want you to notice it's not a U shape, it's not a straight line, it is always going to be a V shape. So absolute value functions, V always have a V shape. So and this again, like I said, is the parent function because it's the simplest version we could possibly have of an absolute value function. We can make changes to this where we make it skinnier or wider, or we make it, we move it from this point so the vertex is now somewhere else. We can flip it over so it is now opening down. There's a lot of ways we can change this absolute value function, but the most basic version is what's called the parent function. But what we're going to focus on today is not just the parent function, but the absolute value function and its transformations. So if this is the transformed version of our parent function, so we can multiply our absolute value by something, and that is a value right here. So we have f of x equals a absolute value x minus h absolute value plus k. A is going to make our graph skinnier or wider depending on the value of A. This is called a stretch or compression, and I'll come back and talk more about that a little bit later. But A is the slope of the right side when we're talking about absolute value graphs. So the A tells you at what rate this right side is moving. So if it's 2, it's going to go up 2 over 1. If it's -1, it's going to go down 1 over 1. But A tells you the slope of the right side, so you can always count on A to tell you how to draw the right side of the graph, and then you know that you'll go the opposite way to make a V for the left side. So you can always graph the other side by just going the opposite to make a V shape. H is the X value of the vertex. H is the X value of the vertex. K is the Y value of the vertex. So our vertex is always going to be the coordinate HK. So we can find our H and K values from here, and they will always tell us what the coordinate point of our vertex is. So just a reminder, your coordinate point always is x comma y. So this tells us the x coordinate of the vertex. This tells us the y coordinate. So x coordinate, y coordinate. Notice that h is negative here, but it's positive here. So whatever it is in here, you switch it when you take it out, or vice versa. So because the equation has a negative sign in it, it's always going to be the opposite when you either take it out or plug it in. So if it had -1 here, you'd write 1 here. If it has 3 here, you'd write -3 here. So we're going to practice that more in just a second, but I'm going to continue on to our first example. So we have the example graph f of x equals 2, absolute value x minus 1, absolute value plus 3. So the first thing I want to do is determine A, H, and K. So I'm going to do this off to the side here. A, I can see is 2. H, I can see here is 1, because remember, look, it says -1, but I always do the opposite sign when I take it out or plug it in. So H is just regular +1, and K will be 3, because K is the number added or subtracted to the end. So notice H is always the number added or subtracted inside the absolute value. K is always the number outside added or subtracted. A is always multiplied. So those are some ways to make sure you're properly identifying A, H, and K. So then I'm going to go ahead and plot the vertex. So I know my vertex is going to be at 1, 3. So I'm going to go to 1, 3 and plot that point on my graph. And then I'm going to plot the points using the slope, which I know the slope here is A. So I'm going to plot the right side. I'm going to go up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1. And again, this is a hand-drawn graph, so it's not going to be perfect, but something like this. So it's up 2 over 1 on this side. And then I know, as I mentioned before, I know I'm going to just go the opposite way to make a V shape. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And now I have a V shape on the other side. So again, I just followed the same thing, but the opposite direction, so it made a V shape. So that's all you have to do to graph an absolute value function, but I want to try one more because there are some other little tricky things you might see. So I'm going to flip the page and have you try a quick check and see if you can get this on your own. So I'm going to flip the page. If you're listening, you can send me a quick email. So again, send me a quick email and let me know that you are listening to this so I know that you are doing what I've asked you to do. So kleary@k12.somerville.ma.us. Send me an email and let me know that you are indeed listening to the notes as I asked you to. Okay, so I want you to graph this one. So pause this video, try it on your own. I'm going to go over it now. So the first thing I'm going to do is identify A, which is -2, H, which is, again, I always have to switch the sign. So since it's positive here, I have to swap it and it's actually negative. And K is -3. So determine A, H, and K. Sorry, excuse my handwriting. Determine A, H, and K. So I'm going to plot the vertex next. So I need to make sure I graph this. So I have my x-axis, my y-axis, and I'm going to go 1, 2, 3, 4, 5, 6, 8. 1, 2, 3. So I gotta go slightly lower. Okay, so I plot my vertex at -1, -3. So again, the vertex is at -1, -3 because it's at H and K. And now my slope is -2. So again, this is telling me the right side. So I'm going to go down 1, 2 over 1, down 1, 2 over 1. And I have the right side of my graph. So notice this time it's actually opening down. So step 3, plot points with slope. And 4 is going to be to draw the line. So now I know to make a V shape, I need to do the same thing, but in the other direction. So I'm going to go down 2 to the left, down 2 to the left. And then I have my absolute value graph. So this time it opens down. So notice when you have a negative A value, you're going to have a graph that opens down. All right, so the last thing, I'm going to do a bunch of writing here, so bear with me. We're actually going to talk about all the transformation terminology. The transformations, these are the changes made to the parent function to make the other functions in the family. So what this means, we just practice graphing other absolute value functions in the function family. So we knew the parent function was just f of x equals absolute value of x, but I applied these transformations and now I have a new graph that's still part of the absolute value family, but it's a different looking graph than the parent function. So we can do that with all sorts of graphs we're going to learn about this year: quadratics, exponential, rational, cubic, any sort of function, square root, lots of functions can start with a parent function, and then you apply these same sorts of transformations, a, h, and k, and you'll get a whole family of functions. So let's talk about vertical transformations first. So the sign on A determines if there is a vertical reflection. So what this means, if A is negative, it opens down. If A is positive, it opens up. So we're going to see this applies to all functions. So if you're multiplying by a negative number in front, then it's going to open down. If you're multiplying by a positive number in front, it's going to open up. The absolute value of A determines the stretch or compression. So I mentioned that briefly in the last page, but the stretch or compression just is the steepness. So this is, again, just the steepness. If the absolute value of A is greater than 1, it gets steeper, which is a stretch. If the absolute value of A is less than 1, it gets wider, which is a compression. So that's a C, sorry. So I say absolute value because the sign on A tells you a different transformation. So A itself tells you if its steepness. So A value where the absolute value is greater than 1 is steeper. So if you had something like -2, like we did in this example, this is steeper than the parent function. It just opens down. So the negative tells you it opens down, but the absolute value of A, it would be 2, and so that tells you it's steeper, rather than if it were 1/2, which would make it wider. K determines the vertical translation. Or shift. You can use either term, so vertical translation or shift. So plus K moves up, minus K moves down. So that's easy. So here we move down 3 because K was negative. If it was plus, we'd move up. And then these are all of our vertical translations. Vertical transformations. So these are all the vertical transformations. We also have horizontal transformations, but this year we're only going to focus on H. So H determines the horizontal translation. So a negative H actually moves it to the right. So it moves it that way. A positive H moves it left, which is that way. So negative moves it to the right, positive moves it to the left. So again, this is sort of opposite what you would expect. So since it was +1 in here, we actually moved it to the left. If it was minus, we move it to the right. So it's always the opposite of what it appears to be in the equation. So horizontal, that's the only one we're focusing on this year. You'll see other horizontal transformations in pre-calc, but not for now. So the last little thing I want to mention is horizontal are written inside the function rule with x. So here, h is our only horizontal transformation. It's the only thing that's inside the absolute value. So horizontal transformations are written inside the absolute value, while vertical transformations are written outside. So notice our A and K are written outside of the function, h is written inside because horizontal are in with the x, vertical are outside with the y. So I know that was a lot for today. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.